In this video we present an immersive light field system, which was built for the European Space Agency's project called Lightfield-enhanced immersive teleoperation system for space station and ground control. System includes the following functionality: data capture, client and server capture software controlling a Canon camera with dual fisheye lens attached to the UR-10 robot arm, data processing, collection of Python scripts for batch image processing and optional depth generation with a neural network, light field authoring, Unity editor project for light field generation and asset bundle exporting, light field rendering, Unity engine components and compute ray tracing shaders for rendering light fields of different types. The panoramic light field is captured by using a spherical pattern. Pictures are taken in 30 rows and 72 columns on a sphere with a diameter of 1.7 meters. The total photo count is 2,160, with pictures being taken every 5 degrees. For datasets of this size, capture time is almost 2 hours. The planar light field is captured by using a flat grid pattern. Pictures are taken in 32 rows and 32 columns on a square with a side length of 1 meter. The total photo count is 1,024, with pictures being taken every 3.5 centimeters. Capture time for this dataset is less than 1 hour. During the data processing step, every image has to be rotated by 180 degrees. Each image has to be split into left and right parts, which should be swapped to match the correct eye. During the light field authoring process, dataset acquisition parameters such as amount of photos and capture direction are specified. The generation parameters include stereo camera baseline, capture volume size, and camera offset from the axis of rotation. The rig parameters section is used to preview the generated capture rig and see individual positions for each camera, as well as textured proxies for left and right eyes. The data parameters section includes a path to a dataset and source texture resolution. It also enables separate data loading for each eye, which is useful for large datasets. The camera parameters section is used to specify initial rendering parameters for the virtual camera and allows the user to select between mono or stereoscopic rendering. The asset bundle parameters section contains a path for saving the asset bundle with a unique name selected by the user. The light field data is generated, previewed, and saved from the play mode. After that, light field data can be built into an asset bundle and exported from the editor mode. This planar light field was created from a grid of 32 by 32 photos. When rendered, it acts like a window to the captured real-world environment. Since 180-degree pictures were used as a source, planar light field has a wide range for viewing angles and perspective change. The planar light field has a zoom-in function, which is not available for a panoramic light field due to a spherical capture volume shape. The planar light field can be used for viewing both foreground and background objects. This light field was initially focused on the model of the helicopter drone, which makes background objects appear out of focus. When focusing on the background, objects further away from the camera will be sharper, while close-range objects will be out of focus. The panoramic light field is rendered on a spherical surface. It is useful for viewing the environment as a whole, but just like a planar light field, it can be refocused. Since the capture volume is quite large, the sampling rate of the panoramic light field is 2 times lower compared to the planar one, even if the dataset is twice as big. The planar light field is more prone to camera placement error, which is most visible near the poles of capture volume. This planar light field was generated from an 8 by 8 image dataset, and each image was split into 32 planes during the data processing step. The parallax effect from each multiplane image compensates for a lower sampling rate and allows the use of relatively sparse datasets, but requires high-quality depth maps and additional processing to eliminate artifacts along the plane edges. This planar light field was captured by using a non-fisheye lens. Despite having a high sampling rate, the use of planar per view proxies instead of half spheres significantly limits viewing angles.